Welcome back, polar bears and polar cubs. Let's talk single replacement reactions. Now, there are two different types. There is the metal way and there's the halogen way. The metal way, the independent, or A, is going to be a metal. We're going to use the activity series located on the back of the periodic table in order to determine whether a reaction will occur or won't. So the main thing that we need to keep in mind is that A is going to be any kind of metal. B is going to be a compound with metal. And that's going to then end up going to the other metal and a compound with a metal. Now I'm going to go ahead and I'm going to go back and kind of color code this for you so you guys can see that what really happens a little bit bigger. What really happens is one metal replaces the other, okay, and kicks it out. So initially, the metal that we have written in black is by itself, and it ends up in the compound in the end. So what this could be called is it's called the cut-in. And by cut-in, it means, hey, there's somebody staying there watching a pair dance. That person wants to then cut in and dance with the other person's partner, that other person that ends up not having a partner to dance with. So let's talk about the activity series. Right here, I took some shots of what the activity series looks like on the back of your periodic table. On the left-hand side, you can see the metal series. It starts with lithium, it goes down. On here, I have it ending with lead, with Pb. However, it actually continues all the way down until gold. So there's a handful beyond this section that is shown. And then the other way that we will talk about here shortly is the halogen way, and that only deals with these four on the halogen series. So what the activity series tells us is it tells us how reactive an element is. So if we go back to the activity series, lithium is more reactive than sodium. So if you're higher up on the element reactivity, you're more reactive, you're more likely to be within a compound. If you're lower on it, like lead is, you're more likely than those above it to be in a compound. So what it ends up telling us is that in our general equation, A plus BX goes to AX plus B, A must be higher on the series than B. If A is not higher than the series, a reaction will not occur. So A must be higher than B in order for a reaction to occur. Right here in the notes, if element A lies above element B in the series, then A will replace B. If B lies above A, then all we're going to write is no RXN on the product side, and we'll be done. The same can be true with halogens. They follow the same rules as 1 and 2. However, they only deal with the halogens, which are anions, not metals that are cations. So the big thing is being able to identify whether it's a halogen or a metal, and then knowing which part of the series to focus on. So we're going to focus with this example first. So the first thing that I want to see is if K, potassium, is above Fe on the activity series. I'm going to go back here and give it a look. So K is near the top. Above that is not Fe, so it must switch over and make a new compound. So you're going to get KCl plus Fe. Now you're going to go ahead and balance it. So we're going to need a 3 here and a 3 here. And we're balanced. And that's single replacement, the metal way. Single replacement also has the halogen way, which then makes it so that X is a halogen. Okay. I'm going to go ahead and do that while I have red on. AY is a compound. Okay. And it has another halogen in it. So, for example, the halogens would be like fluorine, chlorine, bromine, and iodine. So this has one halogen in it. And this then becomes the halogen that is by itself. So metal way, you're replacing cations. Halogen way, you're replacing anions. That's really the major difference. Here is our example. So F2 is our halogen. Cl would be the other halogen. So we're going to go back 2 slides. We're going to look. F happens to be at the top of the list. It wants to react. Cl is below it. So they are going to swap spots. So it becomes Al F3 plus Cl, and this is a diatomic, so it becomes a 2. Now we're going to balance. This just happens to be some of my favorite balancing. It's a 2, a 3, and a 3, based off of the subscripts on our halogens. All right, that's been SR. Go ahead and watch the video on how to complete the worksheet, get that turned in, and let me know if you have any questions.